Welcome to part 3 of this video series whereby we are doing a revision exercise to enhance your understanding of analytical geometry for grade 12. So yeah, we keep it going. This is where we are. We did 2 and 1 in the previous video, so now we are on number 3. On number 3, we're given the points which are A, B, C, and M. M has unknown coordinates, and we are told that these are points on the Cartesian plane. We are required to use analytical methods to determine the coordinates of M so that A, B, C, M in this order is a parallelogram. What is a parallelogram in the first place? Alright, let's also get on eye. They do them sometimes. So yeah, let's try to see. Remember, if you do remember, if the mind serves you well, you'll probably remember the fact that a parallelogram is something like this. It's basically what they call a quadrilateral with this side is parallel to this side, this one is parallel to this one, and this one is equal to that one, this one is also equal to that one, in that fashion. Also, the other thing about a parallelogram is the fact that it has like diagonals which bisect each other. I hope that you also remember. By that, it basically just means that this is equal to that, and then this is equal to that. We need to label the vertices of this parallelogram. We are going to use what we are given there. We're going to say, let's just start from here, A, B, C, and M. As long as you follow the order that you have been provided there, you are fine. Don't have to worry on where A is, where B is, and whatnot. It doesn't affect anything at this point. Or you could have actually tried to maybe, plot these points on a Cartesian plane, but hey, telling you it was just waste time. We don't need to for us to be able to solve this question. So we're not going to do that. Otherwise, if you want to be nice and everything, you can do that. Okay, I'm not sure if you're going to have these points arranged in this order if you do that, but then for the sake of doing what we are required to do, we can just work with this. Okay, what do we need to do? We need to get the coordinates of M. So remember, with regards to the definition of a parallelogram, like I just said, the diagonals, they bisect each other, which means we can just label that point as maybe, let's call it E, that point of intersection there. So what we can do from there is that, we can use the, the formula for the midpoint to get the coordinates of E. Because we know the coordinates of A, we know the coordinates of C, right? So we can use the midpoint formula for those two, for this diagonal AC rather, to get the coordinates of E. Once we have the coordinates of E, look at BM. There we can still use the same midpoint formula, and then we'll be able to get the coordinates of M, which is that Y and X that we are looking for. Okay, I hope you probably see how that can be done. Or alternatively, you can try to equate the gradients, or rather the distances, and then see how that works. But that would require you to use simultaneous equation, because you'll be creating two sets, or two equations rather, with two unknowns in each equation. So you can solve by simultaneous, but that seems like a long shot. So we're just going to use the midpoint approach. Okay, with the midpoint approach, let's get the coordinates of E. Coordinates of E using AC is just going to be XA plus XC all divided by 2. And then we have YA plus YC all divided by 2, just like that. Okay, let's see. We know what the coordinates of this A and C are, so we're just going to substitute 1 plus 4 divided by 2, and okay, 1, this is 4, like that, and then the Y value is 4 plus 4 plus 4 plus 4, or 4 plus 1, or 4 plus 1 actually. Okay, I'll divide by 2 like that, and then now you know the coordinates of E. It's 5 over 2 and 5 over 2, just like that. So now that you have the coordinates of A, you can still use, this is for line AC. You can still use the midpoint formula for which line now? For line BM. Okay, so we're going to apply the midpoint formula again. And however, remember that E is the midpoint in this case, so you already know what the midpoint is. So to write it in this format won't help you like that. So that will therefore mean XE is equals to XM plus XB all divided by 2. And what happens is that XE, you know that is 5 over 2. And that is going to be equals to XM is just X. Wow. What is xb? Xb, you can just go back, it's -2 there, and the yb is 2. Okay, sorry, -2 like that. I'll divide by 2. Then from here you can solve for x -2, then x equals to 7. I hope that is clear. This is x. Okay, also for the y coordinate, that is y of a equals to y of m plus y of b, all divided by 2. Y coordinate is already 5/2. And then what is y of m? That is just y, and y of b, it's actually, which value? You can just go there, it's actually 2. So if it's 2, just gonna put 2 there like that, and then that means 5 equals to y plus 2, therefore y equals to 3. So we have the coordinates of m, guys, as simple as that. X is 7, y is 3. We are done. That's part 3.